Hi, and welcome to this flipped instructional session. This is Middle School Earth Science, and our topic today is Lesson 5.06, Earthquakes, and I am Mrs. Fussell. To start off, we're going to talk about what is an earthquake. Earthquakes happen when tectonic plates move against each other and pressure builds. That stress or pressure can cause the rocks to bend and fold. Sometimes, if the rocks don't bend and fold, the stress builds and builds as the rocks push against each other or slide past each other, and the rocks will break or slip. The sudden release of energy creates waves that can travel far from the break, move the ground, and cause structures to sway and even fall down. And that sudden release of energy, that's what causes the earthquake. So if you look at this picture, at one time, each layer of these rocks sat in flat horizontal layers. The crumpled shape of these layers shows that a tremendous force changed their position. As we mentioned on the last slide, as these rocks folded and bent, stress built up and the rocks moved closer to their current arrangement. In an earthquake, massive amounts of energy is released. It is manifested at the Earth's surface as shaking and property damage. The images below show the destruction after the 1989 Loma Prieta earthquake. An earthquake creates a massive release of energy, which, as we've mentioned, is the built-up stress between two blocks of rock or two tectonic plates that are attempting to move past each other. And they can have horrific results such as this, with the collapse of houses, landslides, and even highways. So earthquakes are caused because, as we've mentioned, the rock does not always fold and bend as the plates move. Sometimes the rock breaks, and as we've discussed in previous lessons, that is called a fault. So a fault is simply a break along which the surrounding rock moves. At these faults, the rock does not always move smoothly. Sometimes it will catch on irregularities, and that's what causes the pressure to build and eventually release in an earthquake. So there are a few different types of faults. The first is a normal fault. They form when the pieces of the crust move away from each other as they are pulled apart. At a normal fault, one piece ends up lower than the other, forming right here this slope or cliff. The boundary type that this forms at is a divergent boundary type because the plates are moving away from each other. In a reverse fault, the opposite thing is happening. The plates are moving towards each other, compressing the crust. One piece pushes over the other and creates this overhang. And at this boundary type would be convergent because the plates are pushing towards each other. Finally, at a strike-slip fault, this is where many earthquakes happen because the plates are sliding against each other in opposite directions. And this is at a transform plate boundary. Strike-slip faults, the plates move sideways and slide against each other, and this is often when they catch, forming an earthquake. So the different parts of an earthquake. The focus is the zone deep within the earth where the rock displacement occurs. So an earthquake isn't actually happening up here at the surface. That's the epicenter, the location on the surface directly above the focus. But the start of the earthquake is deep within the earth at the focus, and oftentimes, as we mentioned, along a fault line. From the focus, seismic waves move outward. Waves are caused by the movements in the Earth's crust. They radiate outwards from the source. Earthquakes cause damage because as these waves reach the surface, they cause the ground to move back and forth or up and down. There are two types of waves. The first one are primary waves or P waves. These compress and expand the ground, kind of like the slinky that you see right here. They can travel through solids, liquids, and gases, and because they move faster, they're the first wave to arrive at a location after the earthquake. These are followed by secondary waves, and this is what actually shakes the ground. It moves as if you wiggle the slinky back and forth, it moves in that direction. So it moves the ground up and down or side to side instead of compressing it. It can only travel through solids and very dense liquids, which this is an important fact for scientists as we're going to talk about in a minute. They move slower than P waves and therefore will arrive at the site second or secondary, hence their name, secondary waves or S waves. So this is just a little chart comparing the different types of waves. Most of these things we've mentioned, that primary waves can travel through solids, liquids, and gases, push and pull materials, travel at 8 kilometers per second and cause the first movement you feel in an earthquake, versus secondary waves, which travel through solids only, with very, very, very dense liquids, makes the rocks vibrate up and down or sideways, travel slower at 4.5 kilometers per second, and as I mentioned, this is usually what is the most damaging. They both originate from the focus, though. They begin at the same time, and they can both be felt. So this is how the waves are useful. Scientists can find out where the focus and epicenter of an earthquake are by comparing the length of time it takes for both waves to travel to a certain spot. The P waves arrive first, and the S waves follow them. So by timing the arrival of the waves, scientists can tell how far their station is from the earthquake. Additionally, it helps scientists to know the depth and density of the layers of the Earth, because the waves travel at different speeds through different materials. So for example, the P waves travel at a different material through the mantle, at a different speed through the liquid outer core, at a different speed through the inner core, and then back out. So that's how scientists have hypothesized that the Earth's core is solid. That the reason they think that the Earth's outer core is liquid is because, as you see here, the blue S waves stop when they reach the liquid outer core because they can't travel through the liquid metal of the outer core. So this is how these waves are very useful to scientists. So many of the earthquakes on Earth occur around the Ring of Fire, which is also where many of the volcanoes on Earth occur. That's because the Pacific Ocean, the Pacific Plate, is going underneath all of these other plates, creating a lot of earthquakes and volcanoes. Many earthquakes also occur right here in California because the North American and the Pacific Plate are sliding past each other right here. That is all we have for today. Please attend the flipped follow-up about earthquakes, and I hope you have a great day. Thank you. Bye.